Other characterization of the signals is related to energy and power of the signals. Before getting into these definitions, we will look into the calculation of energy and power for different types of or for different natures of signal. So let us consider a nature of the signal as one column and formulae as another column. Let us consider a continuous time signal which is non-periodic. So in this case, the energy of the signal can be calculated as E is equal to integral minus infinity to plus infinity mod of x of t whole square dt, and the power of the signal P can be calculated as limit capital T tends to infinity 1 by t integral minus t by t to plus t by 2 mod of x of t whole square dt. Now let us take a continuous time signal which is periodic with period capital T. In this case, energy of the signal E is given as integral minus infinity to plus infinity mod of x of t whole square dt, and power of the signal is given as 1 by t integral minus t by t to plus t by 2 mod of x of t whole square dt. Now let us consider a discrete time signal which is non-periodic. In this case, the energy of the signal is given as limit n tends to infinity sigma n equal to minus infinity to minus n to plus n mod of x of n whole square, and power of the signal is given as limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n to plus n mod of x of n whole square. We see that as the signal is discrete time signal, the integrals are transformed to summations. Now the final category is a discrete time signal and it is periodic with a period of capital N. In this case, the energy of the signal E is given as limit n tends to infinity sigma n equal to minus n to plus n mod of x of n whole square, and the power of the signal is given as 1 by 2n plus 1 sigma n equal to minus n to plus n mod of x of n whole square. So given a signal, first check if it is continuous time or discrete time, then check if it is periodic or non-periodic along with the period. Given this data, use the relevant formulae to calculate the energy and power of the signal. From this, we can define the energy signal and power signal as shown. A signal is called energy signal if its energy is finite, that is 0 less than E less than infinity. Similarly, a signal is called power signal if its power is finite, that is 0 less than P less than infinity. So from this we can see that in case of an energy signal, power tends to 0 or power will be equal to 0, because as energy is finite, when you define for calculation of power, energy divided by time over infinite time would be 0. Similarly, in case of a power signal, energy tends to infinity. As power is finite, when energy is calculated as power multiplied by time, which would it would tend to infinity. Now let us look into some of the examples of energy and power signals. Consider a signal x of n is equal to u of n. We have to find if it is energy or power signal. So the energy of the signal ex of n is given as limit n tends to infinity sigma n equal to minus n to plus n 1. So this would be equal to limit n tends to infinity n, which would tends to infinity. So the signal is not energy signal. Similarly, the power of the signal px is given as limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n2 plus n mod of x of n whole square. So upon substitution, this can be written as limit n tends to infinity n by 2n plus 1. So this can be simplified as 1 by 2 as 10 tends to as n tends to infinity. So the power of the signal px is finite. That implies the signal is power signal. Sorry, as the energy of the signal is not finite, it is not energy signal, and the given signal is power signal as its power is finite. Now let us consider another signal x of t is equal to sine pi by 3t. We have to check if the signal is power signal. We know that the signal is a continuous time signal and it is periodic with a period of t is equal to 6. From this, we see that the power of the signal p is given as 1 by 6 integral minus 3 to plus 3 sine square of pi by 3 t. This would be equal to 1 by 2 upon simplification. So the power of the signal px of t is finite. From this, we see that the power of the given signal is power signal. And also we see that as the signal is power signal, the energy of the signal will not be finite. From this, we see that the given signal is not energy signal. Given a signal x of t is equal to sine of 2 pi t plus 16 sine of 5 pi t, you have to find the power of the signal x of t. We know that given a signal a multiplied by sine of bt, the power of the signal is given as a square by 2. From this, the power of the given signal px can be written as 1 by 2, which is the power of the signal sine 2 pi t, plus 16 square by 2, which is the power of the signal 16 sine 5 pi t. Upon simplification, this becomes 257 by 2. This is the power of the given signal x of t. There is a signal x of n which is given as 1 by 2 whole power n u of n. Check if it is energy signal. We knew that energy of the given signal Ex is given as sigma n equal to minus infinity to plus infinity 1 by 2 whole power n, sorry, mod x of n whole square. This upon simplification becomes sigma n equal to 0 to infinity 1 by 4 whole power n. This can be reduced as 4 by 3. So from this we see that the energy of the given signal is finite. Therefore, the given signal is energy signal. Now let us consider another signal x of n is equal to sine omega naught n. Check if it is energy or power signal. We know that for the given signal x of n, the power px is given as 1 square divided by 2, which is 1 by 2. As the power of the signal is finite, it is power signal. As power of the signal is finite, energy of the signal tends to infinity. From this, we see that the given signal is energy signal. Now let us consider another signal x of n is equal to n into u of n. Check if it is power signal. Here, in this case, the power of the signal Px can be written as limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n to plus n mod of x of n whole square. Upon simplification, this can be reduced as limit n tends to infinity 1 by 2n plus 1 sigma n equal to 0 to n square. This sigma n equal to 0 to n square is sum of the first n squares. So this can be written as a limit n tends to infinity 1 by 2n plus 1 multiplied by n into n plus 1 into 2n plus 1 divided by 6. So upon simplification, we see that this limit tends to infinity. From this, we see that the given signal is not power signal. Now, let us consider another signal. Y of n is equal to 2 into e power j 3n. Check if it is energy or power signal. The energy of the signal Ey is given as sigma n equal to minus infinity to plus infinity mod of y of n whole square. This can be written as sigma n equal to minus infinity to plus infinity for this tends to infinity. Therefore, the given signal is not energy signal. Similarly, the power of the signal Py can be written as a limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n2 plus n mod of y of n whole square. This upon simplification becomes limit n tends to infinity 1 by 2n plus 1 sigma n equal to minus n2 plus n plus n 4. We see this in this case the py tends to, the value of py finally upon simplifying is finite because this is equal to this final value is equal to 4. So the value of py is finite, that is it is 0 less than py less than infinity. From this we see that the given signal is power signal. Therefore the given signal y of n is equal to 2 into e power j 3n is not energy signal and it is power signal. Consider a signal f of t which is of energy E. Given this data, find the energy of the signal f of 2t. We know that the energy of the signal f of t is E. Therefore, EF is equal to E is equal to integral minus infinity to plus infinity mod of f of t whole square dt. From this, the energy of the signal EF dash is given as integral minus infinity to plus infinity mod of f of 2t whole square dt. So upon substituting 2t is equal to p, we know that 2 dt is equal to dp. Therefore, this can be written as integral minus infinity to plus infinity mod of f of p whole square dp by 2. So this can be written as half multiplied by integral minus infinity to plus infinity mod of f of p whole square dp. This is equal to e by 2. Therefore, the energy of the signal f of 2t is equal to e by 2. Now, let us consider another problem. Suppose there is a signal f of t which is of power p. Now calculate the power of the signal f of 2t. We know that the power of the signal f of t is given as pf is equal to p is equal to limit t tends to infinity 1 by 2t plus 1 1 by 2t integral minus t to plus t mod of f of t whole square dt. Now the power of the signal f dash is given as limit t tends to infinity 1 by 2t integral minus t to plus t mod of f of 2t whole square dt. Sorry, actually if f of t is sorry sorry now upon substituting 2t is equal to p, we know that 2 times dt is equal to dp. So this can be written as limit t tends to infinity 1 by 2t integral minus 2t to plus 2t mod of f of p whole square dp divided by 2. This is further equal to limit 2 tends to infinity 2t tends to infinity 1 by 4t integral minus 2t to plus 2t mod of f of p whole square dp. This is equal to p itself. So from this we see that the power of the signal f of 2t is p itself. Now let us consider another signal x of n is equal to delta of n. We have to find if the signal is energy signal. The energy of the signal Ex is given as sigma n equal to minus infinity to plus infinity mod of x of n whole square. This is equal to 1. As the energy of the signal is finite, the given signal is energy signal. Now there is another signal x of n is equal to e power minus n into u of n given. We have to find if the signal is power signal. The power of the signal px is given as sorry we have to find if the signal energy signal. The energy of the signal ex is given as sigma n equal to minus infinity to plus infinity mod of x of n whole square. This is equal to sigma n equal to 0 to infinity e power minus 2n. Upon simplification, we see that this can be written as 1 by 1 minus e power minus 2, because this is a sum of infinite numbers. So as the energy, and this is finite and is positive. As the energy of the signal is finite, we know that the given signal is energy signal. Now let us consider another example in which the signal x of t is given as t into u of t. We have to find if the signal is energy signal. We know that energy of the signal x of t is given as in integral minus infinity to plus infinity mod of x of t whole square dt. This can be written as integral 0 to infinity t square dt, and we know that this integration tends to infinity. From this we can write that the energy of the signal is not finite, so the given signal is not energy signal. Now let us look into last classification of the signals, that is real versus complex signals. A signal x of t or x of n is called real if it takes only real values, that is x of t belongs to r for every t and x of n belongs to r for every n. Otherwise the signal is called complex signal, that is x of t or x of n takes at least one complex value, then it is called complex signal. Now for example, Let us consider the signal x of t is equal to u of t. It takes only real values, that is, it belongs to R for every t. That implies the signal is a real signal. Now, let us consider the signal x of n is equal to mod of 2 plus 3j whole power n mod n. In this case, we see that mod of 2 plus 3j is equal to root 13, and this is whole power of mod n as per the given x of n. So x of n takes only real values, therefore the given signal x of n is a real signal. Now let us consider another signal y of t is equal to 2 plus 3j whole power mod t, and we know that this doesn't belong to R for some values of t, say for t equal to 1. So this is not real signal. So the given signal is complex signal.